In this video, I wanted to look at a couple of applications of the compounding interest formula. Last time we saw what the formula was. It was printed, the future value was given by the present value times 1 plus the annual uh, rate. So the R here was going to be the rate per period. In the example we had down here, we deposited $1,000 at the annual rate of 10% compounded annually. Okay, and the N here was going to be the total number of periods. Total number of periods. And in the case that we had looked at last time, it was going to be for a total of 4 years. And we found that the $1,000 that we deposited became worth $1,464. Now, we calculated that by looking at the $1,000 and multiplying that by 1 plus 0.1 raised to the 4th power. Because in the case here, rate was being compounded annually. Okay, so now let's look at the situation, a little more practical one, because we've mentioned that things are not usually compounded annually. So let's now compound this, say, daily. Okay, so we've got 10% compounded daily. We can put our $1,000 into this account, and then we'll see after 4 years. Well, I don't want to write down all the days in 4 years. Here's year 4. Okay, what is this $1,000 in our account? What's the account going to be worth now? Well, we use the formula up here as we did before. It's going to be the initial value was $1,000 times 1 plus. Now we want to look at the rate per period. In this case, it's the rate per day. Well, if the annual rate was 10%, okay, to find out the daily rate, we have to divide that by 365, because there's 365 days in a year. Okay, and now we want to raise this to the total number of days in 4 years. We take 365 and multiply it by 4. Okay, now to figure out what this is going to be, I'm going to need a calculator, I guess. Sure, I can't do it in my head. Okay, so let's take a look at the calculator here. You want to calculate 1,000 times parentheses 1 plus 0.1 divided by 365. Okay, that'll give me 1 plus the daily rate. Now I want to raise this to a pretty big number here, so I'll put parentheses in just to make sure I don't mess things up. 365 times 4. Okay, so that, whatever that number is going to be the number of days in 4 years. Hit enter, and I see the value is going to come out to be 1491.74. So I'll write that down, 1491.74. Now, observe that we certainly got a lot more money this way than we did when we just were compounding. The account was being compounded just once a year. Okay, so that is a more typical example of how you're using the compounding formula in the case of a savings account. Now, I want to go look at another application, mainly that of inflation. So inflation is a special kind of compounding situation. So we'll take as our example maybe 3% annual inflation. Okay, so let's see what that means. Well, it means that if we were going to look at something that you buy for a fixed amount of money. Say, supposing we wanted to buy $100, and in the year 2000, okay, and we'd like to see then if there's a 3% annual inflation, that in 2001 now, to purchase that same item, the value of that, the cost of that item would have increased by 3%. So we would have had to add to this the 3% of that, just like we were doing with simple interest or compound interest. And so we obviously see that comes out to be $103. Okay, so what that means is it's going to take $103 in 2001 to buy the same item that it cost us $100 for in 2000. Now, let's continue this on. What happens in 2002? Well, again, the price increases by 3%. So it's going to be 3% increasing on the $103. So it would be 103 times that 1 plus 0.03. Now, notice that's going to be the same as if I had taken my original $100 and increased it by 0.03 squared. And if you calculate that out, you see it's going to be a little more than another $3 increase. It's going to be about $106.09. So there's been an extra little increase there. Now, supposing we wanted to figure out what this was going to be in like 2008. Okay, I don't want to do all the in-between years here. So how can we calculate how much would we have to spend in 2008 to buy the same item that we would have bought for $100 in 2000? Well, what's the formula going to be here? It's going to be a special case of the compounding formula. 1.03 raised to the 8th power. Now, I'm not going to be able to do that in my head. So let's see if we can pull up that calculator again. So I can clear it. And what do we want to do? We want to calculate 100 times, 1.03 raised to the 8th power. Okay, and so what's that going to give us? Well, that gives us a little more than $126, almost $127. So the value of this was going to be 126.68. So you see it increased more than just simple interest because of the fact that a simple interest increase would have been, 8 times 3 is 24, so it would have been $124. The price has gone up a little more than that. That's because we're getting inflation applied to the previous inflation value, so that's a compounding type of situation. So this is a version of compound interest. Now, we see how the value of goes up. Now, suppose that we would like to calculate what the effect would be if we were putting our money in this savings account, and we say, well, in 4 years the value is going to be almost $1,500, but it's not going to buy $1,500 in today's value. How much will it buy? Or a special case of that, we could ask, what if I started out, say, we put this money in 2008, and then we would get it back out in 2012. So we could ask, well, what is $1 in 2012 worth in 2008? Okay, well, you see, we could look at this in terms of this kind of scenario, either here or here. If we put in some amount of money P that we would like to figure out what that's going to be. And then 4 years later, since if this is 2008, and this will be 2012, 4 years later we're going to have $1. Then what is that initial amount? In other words, what today will buy what a dollar will be in 4 years. Well, how can we solve that? Well, we go back to our formula here. We can see that what this means is that $1 here is going to be equal to the P times 1.03. That's our inflation rate to the fourth power. Or what we can do is solve for P. P is equal to 1 divided by 1.03, just combine those together, to the fourth power. Now, if you'd rather write everything on one line, we can remember the little rules of algebra that says we can take the exponent from the denominator and move it up by increasing putting a negative value there. All right, so what's that going to be? Well, that I can't do in my head either. So let's figure out what it's going to be here. I have to take, let's say, 1 and divide it by 1.03 raised to the fourth power. So what we're actually doing is discounting that that dollar in 4 years to today's rate. It's going to be about 89 cents. So we can just say 0.89. So basically, in 4 years, $1 will be able to buy the same amount of goods and services as 89 cents does today. Now, if we go back to the question I posed a minute ago, how is this going to affect our value in our savings account? Well, you see what would happen here. I can do the same thing, but I've replaced this value P here by 1491.74 and carry through, and so the present value of that value in the savings account is going to be this discounted by the 1.03 raised to the fourth power, which is just going to be this 89 cents times the 1491. All right, let's see our calculator to see what that's going to be. Well, I've already got it in here, so I can just simplify things by multiplying this by 1491.74, and it gives me 1325.39. So the value of this is going to be 1325.39. So one doesn't really have 1491 in 4 years. The purchasing power of that is somewhat less. Okay, so the point of this is that the compounding interest formula allows one to adjust the value of money between two different periods of time. Here the value of a dollar was adjusted back to today's value. We could also take money at a today or at some period of time and adjust it forwards. Okay, see you in another video.